Let us discuss about amines. Now, first point that amines are derivatives of ammonia molecule. Derivatives of ammonia are replacing hydrogen by an alkyl group or by aryl group. Then we have three types of amines. The first one is called primary amine, when we replace one hydrogen of ammonia, and primary amines contains NH2 group. They have a common name alkylamine, so amine comes as a suffix, and in IUPAC nomenclature they are named as alkanamine. So replace E of the parent hydrocarbon by amine, alkanamine. Then we have 2-degree amines, when we replace two hydrogens of ammonia. So they have a general formula RNHR-, and these two alkyl groups, they may be same, they may be different. So in the common name they are named as dialkylamine if both the alkyl groups are identical, and in IUPAC system they are named as N-alkyl alkanamine. N-alkyl alkanamine. So N stands for nitrogen. Then we have 3-degree amines, when we replace all three hydrogens of ammonia. So 3-degree amine contains only N, and 2-degree amine contains NH, and 3-degree amines have a common name trialkylamines if all three alkyl groups are identical. Otherwise they are in the IUPAC system they are named as N, N dialkyl alkanamine if two alkyl groups are identical and one is different. If all three are different, then we write N-alkyl alkanamine. Now these are some examples. Now this is called primary amine, since we have a NH2 group present. It has a common name called N-propylamine, and IUPAC name is propanamine. Now second example is this CH3CH2 CHNH CH3 and CH3. Now this has a common name called methyl sec-butylamine, and IUPAC name is N-methyl butane 2-amine. Now this is another example which is named as trimethylamine, common name trimethylamine, and IUPAC name is N, N dimethyl methanamine. This is IUPAC name. Now next, when we have a NH2 group directly bonded to benzene, then this is called a benzenamine. It's an aromatic amine, benzenamine, which has a common name called aniline or is called phenylamine. Phenylamine. Now some more examples. Now this is an example of a 2-degree amine, since we have a NH group present. Now it is named as N-methyl 4-nitro benzenamine. 4-nitro benzenamine. Then we have a quaternary salts, quaternary ammonium salts. They have a general formula R4 N positive and X negative. If all four alkyl groups are identical, so they are named as tetraalkyl ammonium halide. Ammonium halide. Now, for example, we have this one CH3 whole 4 N positive and Br negative. This is named as tetramethyl ammonium bromide. And if they are different, you arrange them alphabetically. For example, we have C2H5 whole thrice N positive, C6H5 stands for phenyl, and this is OH negative. This is a hydroxide and it is named as triethyl phenyl ammonium hydroxide. Now next we will discuss about the preparation of amines, and there are a number of methods to prepare amines. And the first method is called reduction, and reduction is defined as the gain of hydrogen or loss of oxygen. So amines we can prepare by the reduction of this nitro group using iron in hydrochloric acid or tin in hydrochloric acid. This is a method we use in the commercial scale and is used to prepare the primary amines. Now we can also reduce the cyanides, nitriles by using sodium and alcohol as a reducing agent, or we can use lithium aluminium hydride. It gives a primary amine with the same number of carbon atoms. So CN group can be reduced to CH2NH2. We can also reduce the amide functional group CONH2. This is called amide functional group by using lithium aluminium hydride. It changes to CH2NH2. Basically, lithium aluminium hydride converts the CO group into CH2. It's a primary amine. So each one is primary, but we can also reduce the isocyanides NC group using H2 nickel or H2 platinum into a 2-degree amine. So the compound contains NH group, so this is called 2-degree amine. It's named as N-methyl alkanamine. So this is the first method called reduction. Now let us take one or two examples. Now this is the example given CH3, CH3, CO and NH2. Now we are reducing it with the lithium aluminium hydride. So this only converts the CO group into CH2. There is no change in the number of carbon atoms, no change in the arrangement of carbon atoms. So this is the amine produced. Similarly, if we are reducing this one, this is isocyanide using H2 platinum or H2 nickel, it gives CH3CH. So there is no change in the R group. R group remains as it is. Only NC group changes to NHCH3. So this is 2-degree amine and it is named as N-methyl propane 2 amine. And this is our longest chain of 3 carbon atoms. Now we have one more example. This is called 1,3-dinitrobenzene. And we are reducing it with iron in hydrochloric acid. So iron in hydrochloric acid reduces both the nitro groups into NH2. So the product is benzene 1,2 diamine. Now the second method is, this is nucleophilic substitution using haloalkanes and ammonia. Ammonia is a nucleophile, so this alkyl halide on reaction with ammonia, it's a SN2 reaction, gives RNH2. Now this is a primary amine. So this is a reaction involving the breaking of CX bond. This reaction is called Hofmann ammonolysis. Hofmann ammonolysis. So we are breaking the bond with the help of ammonia. That's why it's called ammonolysis. Now this RNH2 further reacts with the same alkyl halide to give a 2-degree amine. This is 2 degree. So this reaction of haloalkane with ammonia gives a mixture of amines. So this is not a very good method to prepare amines. And if we are using alkyl halide with ammonia in excess, then it gives primary amine as a major product, but it does not mean that other amines are not formed. Other amines are also formed. For example, if we are using CH3Br with ammonia in excess, it gives methylamine as a major product. Now the third method is, this is called Hofmann Bromamide reaction. This is also called Hofmann hypobromite reaction. And this is also called Hofmann degradation method. And degradation because there is a loss of carbon atom in this case. Degradation method. So in this reaction we treat the amides containing alpha carbon atom, amides with alpha carbon, with bromine and alkali. Alkali can be KOH, NaOH, you can use any one, and warm. It gives a primary amine with 1 carbon less. And the side products are KBr if we are using KOH, and K2CO3 and water. So in this case there is a loss of this CO group in the form of a carbonate. So in the forward direction you just eliminate this. In the backward direction you insert CO group here. Insert CO group here. Now this is Hofmann bromide. We take one example, CH3CH2 and CONH2 when treated with bromine and alkali, we can write NaOH, we can write KOH. So there is a loss of this group, and as a result the product obtained, the major product of this reaction is ethylamine. And similarly, if you are given an amide A and we are treating it with a sodium hypobromide, NaOBr, bromine and NaOH they combine to give sodium hypobromide, it gives a product called phenylamine. Now question is, what is the structure of the amide A? Now this is phenylamine and this is a Hofmann bromide reaction. So in the backward direction you insert CO group here. As a result, the structure of the compound A is this, which is called a benzamide. This is called a benzamide. Now the fourth method to prepare amines is called the Gabrielthalamide synthesis. Gabrielthalamide synthesis. This also involves SN2 reaction. Now this is phthalimide, and we react this compound first with KOH. It's the acid-base reaction to give a salt. Now this salt is obtained in which this part is our nucleophile, and this nucleophile then displaces the halide of the alkyl halide via SN2 mechanism to give this N-alkyl phthalimide. So this is N-alkyl, and which on hydrolysis gives RNH2. So if you look at this reaction, only the X of this haloalkane has been replaced by NH2. So this method is, first point, this method is exclusively used for the preparation of primary amines. Because only one hydrogen bonded to N atom. As a result, only one alkyl group can be attached to nitrogen, and hence only primary amines. Also, this is an example of a SN2 which is given by less crowded alkyl halide, and hence only primary amines can be prepared. The next point is that aniline cannot be prepared by Gabriel method. Aniline cannot be prepared by this method because the corresponding halobenzene does not undergo or does not give nucleophilic substitution reaction. The carbon halogen bond has a partial double bond character. Partial double bond character due to resonance. And hence X cannot be displaced, aniline cannot be prepared by Gabriel method. So whichever amine you want to prepare by the Gabriel method, use the corresponding alkyl halide in the second step. For example, we can prepare ethylamine by Gabriel method. So this is the reaction involved. This is phthalimide. So we are reacting it with KOH in the first step and followed by reaction with ethyl halide to give N-ethyl phthalimide. And then we hydrolyze this using water and KOH. It gives CH3, CH2, NH2. So this Gabriel method is used exclusively for the preparation of primary amines. Hofmann Bromamide is used to reduce the number of carbon atoms, while reduction is used to keep the number of carbons same. Now next we'll discuss about the physical properties of amines. Physical properties of amines. And the first point is the boiling point. Now amines have a higher boiling point than haloalkanes. Higher boiling point than haloalkanes. And this is due to the fact that amines are associated via intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Now second point is that amines have a lower boiling point than alcohols. Have a lower boiling point than alcohols or carboxylic acid. The reason is that nitrogen is larger in size and less electronegative than oxygen. Therefore, the NH bond is less polar than OH bond. As a result, amines are less associated via hydrogen bonding than alcohols, and hence amines have a lower boiling point than alcohols. Amines have a lower boiling point than alcohols. So in general, the boiling point order is this. This is a hydrocarbon where you have only weak van der Waals forces present. Then we have haloalkanes, ethers, aldehyde, ketones. Now these four compounds have dipole-dipole attraction. Dipole-dipole. Then we have amines, alcohols, and acids. Now these three have hydrogen bonding present. Now second point is the solubility. The lower amines like methylamine, ethylamine are completely miscible in water, due to their ability to form hydrogen bonds with water. Now aniline is immiscible cannot form hydrogen bonds with water due to the bulky non-polar hydrophobic benzene ring. So this is about the preparation of amines and the physical properties of amines.